depth first search technique. The first key point, as you can write, is the same as it is followed. Uninformed search technique. Uninformed search technique in which we do not have knowledge about the domain of the problem in advance. Okay. The second key point is, as breadth first search technique use the concept of queue or queue, in depth first search technique we use stack data structure. Which principle is follows? Unmute your mic and speak. Which principle stack follow?
Sir, first come, last out.
Yes, LIFO. What the element you enter last, it will come out first. Okay. So let's. What are the operation of stack? What are the operation of stack data structure?
Sir, push, pop, and वही जो उसमें थे मतलब
Yes,
is full is empty.
is empty, full, and these are the operation. I'm sure you all know about all the operation. Push means enter the element into a stack, and pop is the operation which remove the element of the stack. So the top element, always you remove the top element of the stack. Okay, good. Okay, so let's see the depth first search technique, how it's works. Yeah, as you can see, there is one tree I just drawn. Okay, so start from state A. It use the concept of stack. So let's draw the A. Let's draw the stack and enter the element, top element, which is A. Because we are starting from this, enter the start state into your stack. This is stack, okay? And remove the top element of the stack and enter the state from which you can move from the current state. From, as you can know, we are removing the state A from the stack, and from A there's a two path, B or C. There is a two path we can follow or we can explore from state A, which is B or C. So you can choose any one out of these two paths. Okay, you can choose B or C. It is your choice. Okay, you can enter B into your stack, or you can enter C into your stack. It is your choice, but you can enter only one state only at a time. Okay, is it clear? So I'm just see, I'm just entering B into our stack. So I'm just following this stack, and from state B, remove B from state. You just always parallelly you write which state you are removing. First we state remove A, then remove B, and if we remove the B, what are the possibilities or what are the possible path from A to explore? As you can see, D and E are the two options. You can either enter the D into your stack or E into your stack. Now I'm just entering D into my stack. Okay. Now D is my top stack. Okay. So from D, what are the next node we can explore? From D, as you can see, there is no path to explore. Okay. So you will remove D from your stack, and now you are explore the B's from the B. What are the remain path? From the B, what are the remain path? From the B, we have explored D, but E is the remain path. So you will enter the E into your stack, and now exploring this state E. There is no other state from E. So again, you will remove E from the stack and add this into this sequence. Okay. Now B, again from B, what are the state we can explore? From B, as you can see, explore the D and D. There's no other state are remain to explore. So you are exploring the B has been completed. Okay, so move to the next level, which is A. From the state A, what are the state you can explore? From the A, you can explore B and C. We already you have explored, so there is no need to explore the B. Start from C. So enter the element C into your stack and start explore. Okay, so remove then C from the stack, and that from the C, how many state you can explore? F and G. Out of these, to select one state. You can select any E, F or G. It is your choice. I'm just exploring F. So entering the F element to my stack and exploring. And if I explore the F, from the F, there is no other state. So remove F from the stack. Okay. The next from the F, you from this F you reached from the C. So start explore the C again. From the C you can explore state G. So explode it completely. It means enter the element G and start exploring. See, there is no other state, so you can remove it and put it here. And now from the G you reached at G state you reached from the C. So again explore the C. As you can see, though no other state are remain to explore. So again you will jump to A. Means what are the initial state, and check the any other state that remain to explore was state A. There is no state remain for explosion, so we'll stop. Okay, you have reached to your initial state from where you start, and you have not reached to any goal state, so you will stop exploring because there is no goal in your state space. Okay, so you will stop. Okay, so if you can see, this is the one possible path or sequence you can explore from your state A. A, B, just drawing. You start from A, move to B, then D, A, B, D, then you move to E, then go back to B and A, then start C, then you explore F, then G, and go back to A. In this path, you follow to exploring your goal state. Okay. So this 1 minute. So I can say this depth first search technique followed deepest node. Deepest node principle means it will explode from one end, start exploding one end, and it will explode till the reach to the deepest possible state. And if it is found goal state, it will stop. Otherwise, it will reach to the deepest point. And if it is not found, it will start backtracking. Okay. If it is start from A, then B, then D, it is reached to the deepest point. It is not able not find the goal state. It start backtracking. It will go back to B and again start the next branch, and it will explore till the deepest point. And if it is found, it will stop. Otherwise, again it will start backtracking. Okay, so it follows deepest node. Will reach to the deepest point. Then if it is found, it's good. Otherwise, it will start backtracking. It follows deepest node principle. And one other point is incomplete. This search technique is incomplete. Means, as you remember, breadth first search technique is complete. If there is a goal state, it will uh, find. Anyhow, it will find its goal state. But depth first search technique not gives that guarantee. If there is a goal state, but maybe depth first search technique is not able to find that incomplete, not able to find that goal state. Because suppose your G is goal state, just consider your C is goal state, and you start exploring this child or this path you followed, and you reach to this and this and this, and you exploring to the one end, and it is what I can say, it's there is a n number of state, means infinite number of state are in this path. Okay, or there is a chance of loop, you stuck in any loop, and you are stuck in that loop, and what the goal state is the next state from the start state, and you are stuck into one loop, and you are exploring that state continuously. Okay, or you stuck in is one child, which is uh, there is an infinite number of state. Okay, so it is not give you the guarantee, it will give you the uh, goal state. The next key point is non-optimal. It is not even also guarantee for the optimal solution. Okay, there is a c is one optimal solution, and it will it is exploring the it's one branch, and let's suppose the depth for it find, then another goal is state, and which is more the cost is higher compared to this state one state c, which is less cost. Okay, so it will give you this result which is costly compared to this another board. So it all not even give you the optimal solution. And the time complexity, as you can talk the same, the time complexity of both the search technique is b power of b to d, where b is the branching factor and d is the depth of the search space. Is it clear? Is it clear to all of you?
Sir,
Yes, please.
as we are saying that depth can be infinite,
Mhm.
so can we say that breadth can also be infinite?
That can be infinite. I think no. There's a chance. There's a many breadth, but can not be infinite, because the move are legal always. When you playing any game or any, if you took any problem, there is a legal move are limited or the finite. You can say there's an n number of option I have. Okay, for one state to another state, there is some finite number of finite number of move, but not infinite. Okay, maybe there is a large number of move or large number of valid state or possible, but it will always will be finite. Okay,
Okay, sir.
so branching vector, I'm sure it will not be infinite. Okay, okay. Any other doubt or any other confusion? Okay, so let's see the algorithm for these two search technique. The breadth first search technique, first it create a variable node, and it sets the set it to the initial state. What we have seen, there is a one list we create, and that list we will start from the initial state, and the first element we will enter into this node list data structure. Okay, until the second point is, until a goal state is found, node list is be empty. Okay, so we will we will start exploring, and if we found the goal state, we will stop, or we will stop when our node list will be empty. Okay, the first remove the first element from the node list what we have created as a cube, and call what the element at the top, what the element we are removing from the queue, we are giving as a e, or the exploring element, exploring a node. Okay, what the element which is top of the list, top of the cube, or we can say at the head, we will remove, and we'll call it as the exploring node. Exploring node. Okay, as you, even you can say simply E. If the node list was empty, then quit. Means if we remove that element from the queue, and the queue is empty, we will stop, because we have explored all the possible states. Okay, the next is, for each way that each rule can be matched described in E2. First, apply the rule to generate the new state. What we have seen, generate the new state means remove that state and enter that state which are exploring from that current exploring node. If the new state what we have exploring is goal state, we will stop and return the state, the path from that we can reach. Otherwise, the add the new what we've seen. Otherwise, add the new state at the end of the node list. Let's see. This is your graph for the breadth first search. You are starting from the state A. A is the start state and G is the final state. Okay, for the goal state to be searched. Okay, and the node list we will start from node list. We will start from the initial state. First, we enter the initial state into our this list, or what we can call it queue initially. Okay, and expanding or exploring this state A. If we explore this state A, there is a two path, or the two next state are possible, which is B and C. Means from A you can reach B and C. So we will remove state A from the node list and add this B and C into our node list. As you can see here, B and C we have added. Now out of this B, we will explore B first, because B is the top element of this queue. Okay, so now explore the B, and from the B there is an E and D are the two possible state. Means it is exploring a state. B is exploring state. Okay, so we enter this D and E into our queue from the back. Okay, as you can see, we are entering the element from the back, D and E. Now C is the top, so we will explore the C and state, and from the C we can reach D and G are the two possible state. So we are at D, we already explored, so there is no there's no need to enter D element again. So enter the only G state. We have explored the G state at the end of the queue. Now as you can see, D at the top, so explore the D state. We are exploring D state, and from the D there is only one way where we from D you can reach only F state. So F we have added into our back of the queue. Now you can see E is the top of the queue. So explore the E, and there's no path from E. So just there's no need to enter any element. G and F is the only element now remain into your node list. Now you can see G is the top of the queue, or node list. Now explore the G. As you can see, G is your goal state. G is your goal state. So you will you have reached to your goal state. So there is no need to explore again and stop it. From G you will stop because you have reached to your goal state. Okay. So this is the traverse order we have followed. First we have start explore A, then B, then C, D, and E. A level we are exploring. First we explored the state A, is one level. Then in level B there is these two states. Okay. Then this is level 3. Okay. Then it's level 4. Okay. So in this level we are following or traversing our tree. Graph here. This is the traversing order. Okay. So, is it clear to all of you? Brad first search. If it is clear, you can write in chat yes or clear, so I can start the depth first search. Okay, clear. Okay, thank you. So the next is depth first search technique. First see the algorithm. If the initial state is goal state, quit and return is obvious. If your initial state or the first state from your starting is goal state, you will quit. Okay. Otherwise, do the following until success or failure is reported. First, generate successor. What we call is E, or the exploring state. For the initial state, generate successor of E. What the state which is the top of the state, we are calling it exploring state. or simply we call it E state. If there is no more successor, if we exploring the state and from the E there is no other successor is found, we will signal as a failure, or because we have not reached to our goal state. Call depth first search with E means explore the E as the start state. If there are no more successor, then signal failure. If successor obtained, return successor, and otherwise continue in this loop. Let's see. This is our graph for depth first search technique. We start from the state A, and we have insert this element A into our this stack DFS. Okay, and exploring A. From A, there is a two possible way, B and C, but we choose B. You can choose C as well. Okay, there is a one other sequence we will get. Okay, it is also correct. Okay, so I've just select B as in my next successor state. So from exploring B, so remove A from the top of the stack and enter the element B. From B, there is an again two possible path E and D. It select E as the next successor. Okay, so exploring E, if there's no other successor we found, so you will return or backtrack from which you reach to E. So you reach to E from the B, so you will backtrack. So now you are reach to B and explore the B again. So from B you traverse E, that D is only remaining state, so you will exploring state D. You explore the D, and that from D there is an again two possible paths, C or F. You choose any C or F. Here it is choosing F. So it explore F, and F again there's a two path G and H, but it is selecting H. So it will select explore the H. From the H there is no other state, so it will backtrack. This to F. Okay, these two backtrack F, and again find we'll see any other state remain to explore. As you can see, there is an H is explored, but G is remained, so it will explode G. It's exploding G, and it is comparing G. What you are exploring, it's a goal state, so we will stop. Whenever you see what the state you are exploring, always you will compare with the goal state. Is it goal state or not? It is goal state or not? And as you can see, G is goal state, so you will found your goal state and return the path from G you have reached. As you can see, this path you have followed to reach the G, which is A, B, D, F, and G. So this is your path which follow to reach from state A to G. You start A to B, then B to D, then D to F, then G. This is the path you follow to reach from state A to state G, which is your goal state. So let's see what are the advantages and disadvantages of BFS and DFS. So the first advantages of BFS is a systematic search strategy. All nodes at level N are considered before going to next level. As you can see, it exploring the level by level. It will explore the first nth level. It will completely explore. Then it will move to the next level, which is n plus 1 level. Okay. So it is systematic search. It will not remaining any state to unsearched or unexplored. Okay. So we are calling it a systematic search strategy. The next advantage is if any solution exists, then BFS guarantee find it. If there is any solution, if there is any path to reach from your start state to goal state, it's ultimately find it. Okay. Means it will give it is giving you guarantee. If there is a solution, it will return you. If there are many solution, BFS give you means always it give you optimal solution. If there is a many possible path from state from start state to goal state, it will give you the what is the optimal solution. And it will never trapped exploring blindly means it will never trapped in any loop means because it's exploring level by level by level. It is not stacking in any loop. If there is a graph and there is the graph there is a loop, it will guarantee BFS will not stack in that loop. What are the disadvantages of BFS? All nodes are generated at any level, so even unwanted nodes are remembered, and means it's a memory wastage. Means what are the all the what are the state or possible in your state space is explored, and always remember what are the path we are following. Okay, So unnecessary or necessary, what you call it, will save the state, all the state in your memory. Okay. And it's the time complexity complexity exponential, as you can see, the time complexity of this breadth-first search technique b to the power d, which is exploring time complexity. And what is the advantage of DFS? DFS is memory requirement. It's less compared to BFS because it's remember the only path which are currently following. What the path we have already followed, it is not remembered. Okay. And DFS may find a solution without examining much of the space search of all, means what the solution is find first, it will return. Means unnecessary, it's not exploring the whole search space. Okay, what the solution is find first, it will return you. What is the disadvantage of BFS? Actually, it should be DFS. The search can go on deeper and deeper into the search space, thus it get lost. Means what I just said, if there is an 1 minute, if it is your start state and exploring this state, and this is space is infinite number of states, so it will explore till the reach to the deepest point. So it will be stuck in this way, or it may be stuck in a one loop of your graph. Okay, so this is one disadvantage of DFS. Actually, this is DFS. Okay, so this is the all about DFS and BFS. Okay, if you have any doubt, you can ask. Otherwise, write the attendance in chat. Write K for kite in attendance.